Hi and welcome to another presentation, training tutorial on networking, tools and tables. The agenda today will cover a couple of analogies that I find are very useful for explaining networking concepts for people that are not familiar with networking. We're going to discuss two free TCP/IP tools that you can use, and we'll discuss some URLs that I find very useful and some information that I put together to speed up things for me when I'm looking up information. For those of you who are not familiar with me, I'm an IT manager and I work for a software company. I've been in the industry for over 25 years. I consider myself a generalist with a decent knowledge of TCP/IP and networking, but I'm definitely not an expert. So I don't claim to be an expert, so let's just say that much. Okay. Who is my target audience for this presentation is basically other generalists like myself whose maybe networking skills are not so strong. For someone who doesn't handle networking issues very often, or for someone who thinks networking is like voodoo magic, things happen somehow, they work. Or for people in IT who have a hard time explaining networking concepts to others. The first analogy that I'm going to use is the postal service. The postal service I find is a great analogy because it's very similar to what networking is all about. For instance, a network packet in networking is very similar to an envelope. Some people might say, what is a network packet? Well, it's simply a transport mechanism for a computer to be able to communicate with other computers, either on your local network or through the internet. Very like an envelope, like a regular envelope, a networking packet always contains a source and destination IP address, so that it knows where to go and it knows how to come back. That's exactly what you do when you write on an envelope an address where your envelope is going, and in case you cannot deliver it, in the upper left corner you put your own address so that the letter knows where to come back to in case it doesn't get delivered. Also, in a networking environment, you have port information inside a packet header. Now the port information would be like, let's say, port 25, which would tell you something like it's a SMTP packet, which means it's an email, or let's say port 80. If port is 80 here, it tells you it's a web packet, right? It's information about you're surfing the web, most likely. So that kind of information would be seen on an envelope. For instance, if you put the word fragile, or treat carefully, because the content of the envelope is delicate. You want people to manipulate the envelope, very carefully. So without opening the envelope, the information that is on the envelope gives them an indication of what's inside. So in a networking environment, the source information, the source port number, is used by, let's say, by firewalls to know what's inside and be able to direct the packet to the appropriate servers or machine based on the port number, right? So for instance, if it sees information about the SMTP, or it knows to redirect that towards the mail server and so forth. Okay. Sometimes in a networking environment, you'll hear people talk about encapsulation or encryption, right? Which is typically done in a VPN setup, in a VPN tunnel. Now, the word encapsulation here means you're putting a full packet, inside of another packet, and you're encrypting it so people cannot read it. Okay. Now, if you compare that to the analogy of the postal service. Consider the idea of, let's say you have two offices, one in Houston and one in New York. And, people in Houston have either letters or documents or contracts they want to send to New York. So what they'll do is they'll put that in one of those inter-office envelopes, and they'll say, this envelope needs to go to Bob in New York. So what they'll do, they'll give these envelopes to the receptionist, who at the end of the day or at the end of the week will put all these envelopes into a FedEx envelope and ship it to New York. And people in New York do the same thing. Any paper that is destined for Houston, they'll put it in those kind of envelopes, and the receptionist in New York will FedEx it to Houston. So that's the analogy here that is the same, where it's an envelope inside an envelope. Okay. However, where the analogy kind of falls apart a bit here is, let's say I have a book, okay, and I take this one book, I put it to one envelope in a FedEx envelope, and I ship it out. Well, if the book, let's say, is 100, 200, or 300 pages, the electronic version of that book, if I want to do the same thing via a network, right? Let's say I want to attach the PDF version of the book, and I want to attach it as an email attachment, right? So maybe the book is equivalent to a 10 meg email attachment, PDF, right? So this email that I'm going to send with this attachment will be thousands of packets going through the network and reassemble at the other end to deliver that one email. Now, why do I say thousands of packets? Because a packet itself, right, the whole packet usually is never bigger than 1,500 bytes. And at that 1,500 bytes, about 500 of that is assigned to the header section, like that stores information about the address, where it's coming from, where it's going, and those other the type of information. So the data portion of the packet itself here is about just 1,000 bytes. And for those of you who are not familiar with what a byte is basically like a letter or a number. So for instance, number 450, right, that's 3 bytes. A byte for the 4, a byte for the 5, and a byte for the 0. Same thing with letter M. Letter M is 1 byte. The word left is 4 bytes because it's 4 letters, right? L-E-F-T. So as you can see here, a packet can only contain 1,000 of these things. So to include a book of 300 pages, you're going to require a heck of a lot of packets to be able to send all that information through the network, so at the other end it gets reassembled and delivered as an email. Okay, so this is what we're talking about here. Now, the other analogy that is really good to explain networking concepts is the road system. Now, the road system here is, you could say, well, a network address, which is basically here the IP address, let's say, of your computer at your office, is equivalent to your house IP address, right, where you live. A network, or a VLAN, right, is equivalent to a street name. So the street name where you live, it would be your network or your VLAN that your computer is on at the office. A network mask, right, kind of indicates the maximum number of houses you can have on your street. Also, where again the analogy falls a bit apart here, is the default gateway of a computer, right, is equivalent to a house on your street. Well, I say a house here, but more likely it would be more like a bridge or a tunnel. And that tunnel or that bridge would have an IP, an address, where the only way to get in and out of your street is through that bridge. So anything that's destined for the outside world would have to go through that bridge to get onto your street, and vice versa. Okay, your office LAN, right, is like a small town, because a town can have one or more streets. Remember a street before I said it's a network or a VLAN? Well, where I work, we have over, let's say, 8 networks or 8 VLANs. So that's equivalent to 8 streets. So my town consists of 8 streets. Okay, the internet is like a highway that links all the towns. A routing device, okay, is like a street intersection. And the brains of a routing device is like a traffic cop directing traffic, right? So because when you're traveling on the road and you come to an intersection where you have 3 ways to go from the intersection, if you don't know where you're going and there's a traffic cop there, you'll ask him, okay, I'm going to this place. How do I get there? He's going to tell you, okay, you go left, go straight, or go right, right? So the same thing here applies in networking. For some of us, even words and analogies are not good enough or not sufficient to be able to understand a concept. So for us, a lot of us, or some of us, maybe the older generations, you need a visual, aid to be able to explain things. So in this example here, we have, this is basically your network at the office. So let's say you've set up a brand new office, you've set up your network at the office, and now you've put together a mail server. You've set up your website on a server. You have an application that's running on a server here that you want people to be able to access from the internet and so forth, right? You got all these different devices here. So now you call your an ISP. So you sign your contract with the ISP, and you've agreed that you're going to be using a special link here so that to be able to connect to the internet. So the ISP comes and basically he physically connects your office to his network. So what he basically does here, he creates this road. Okay, and what he does is he's going to put a routing device at your location, a router, to be able to route traffic from your servers through the link back to the head office of the ISP, through his own network, and then onto the internet, and vice versa. Okay. Now, so in this example here, it seems that the customer here has basically signed up for a T1 internet access. Now, the reason I say this is because a T1 is equivalent to this speed here. It's 1500 kilobits per second, or 1.5 megabits per second upload and download speed. So any traffic going through here is going to go at this speed. Okay, so this is what represents an ISP router at your location, the ISP link that they've installed for you, and the rest here is basically their network that allows you to reach the outside world. Okay, so this is basically concludes the analogies that I was trying to explain to you. Now, the next part here we're talking about is the two free TCP/IP tools that you can use to troubleshoot issues. Now, a lot of you will be very disappointed to find out that I'm talking about ping and traceroute. But ultimately, these are the tools that every networking device usually is able to run on their OS in order for you to troubleshoot issues. Okay, so let's say, for instance, you're in Houston and you're trying to go to yahoo.com or google.com, wherever you want to go. And obviously you're surfing the web and you find the pages are loading very slowly in your browser. And like it's very, very slow. So you can do a ping to yahoo.com to find out how fast it is, right? So let's say you get results of 300 milliseconds, right? So this kind of confirms that there's a problem trying to reach that server. You just confirm with numbers that the result you're seeing in your web browser is confirmed by doing a ping. Because usually, no matter where you are, you could say North America, pinging Yahoo should be less than, I would say probably 50 milliseconds, if not 30 milliseconds. So if you're getting something in the hundreds or 200s, then obviously there's a problem. Okay. Now, if you have a problem like that, then the next step is try to find out where the problem is. Okay, so traceroute is what you would use to identify where the problem potentially is occurring. So a traceroute identifies all the routing devices along the way to reach your destination. Okay, like I said earlier, a routing device is like a street intersection where there's a traffic cop there, if you're going to refer to my analogy from earlier. So let's say from Houston you're trying to go to yahoo.com, so you do a traceroute to yahoo.com, and it shows you that there's like 7 hops to get to your destination. Okay, you may find that all of a sudden you see that hop number 5, right, is really bad, like it's in a 300 millisecond range. So you have to run these tools multiple times to get a sense of if what you're seeing is really representative of the current state. Networking is very, very, very fast. You can run the one command and half a second later you run it again and you can get different results. Okay, so you cannot just run it once and say these are the numbers I see right now and therefore that's what it must be. So you need to determine that you need to run them multiple times to get a sense, to get an average of what the traceroute and the ping results will give you, so that you can provide that information to your ISP to help them troubleshoot the issue. Okay. The little quick note here that I have at the bottom is, if you're going to be doing a traceroute through a VPN tunnel and you're going to try to traceroute a private IP address at the other end of the tunnel, it's kind of pointless because it's not going to give you all the hops, the physical hops that it goes through on the internet. It's just going to go through the tunnel and give you a result at the other end. So I would not even bother using these numbers as valuable information to give to an ISP to troubleshoot. So you should always use a public IP address when you're doing traceroute or ping. Well, at least traceroute. These are some of the common URLs that I found to be very useful. The top three are basically related to giving information about IP addresses. For instance, let's say you have your website or your internet link or your company is being attacked, or you're seeing a lot of traffic from an IP address that you're not familiar with. You can use those three sites to find out more information about an IP address. So, for instance, you could use them to find out that an IP address that you're seeing a lot of traffic on your internet link. And these sites may tell you it's coming from the Philippines, or it's coming from China, or it's coming from East Germany. And obviously, if you know that you're not doing any business with those countries, then obviously that gives you an information that, okay, maybe someone's trying to hack me, or somebody's trying to break in, or trying to generate traffic to slow me down, to give me a DOS attack, that kind of stuff. So these tools are there to basically tell you information about about the IP address information that you're seeing, where it's coming from. Cloud Monitor is a redirector for justping.com. I love this site because what it does, it pings an IP address from 50 different locations in the world. So let's go back to our example earlier. You're in Houston, and let's say you're trying to access your web server that is located in your New York office, and you find that performance is really slow, right? Your website is crawling from when you try to access it from Houston. So if you go to this location and you put in the IP address of your web server in New York, it's going to ping it from 50 different locations in the world, and it's going to give you the results. Okay, out of those 50 locations, 2 of them are from Texas. One is from Houston, one's from Dallas. So if their ping results from these locations for Houston and Dallas gives you about, let's say, 50 milliseconds, and you're in your Houston office on your computer and you're seeing 300 milliseconds, again, it's more proof, more ammunition that you can provide to your ISP and give them and tell them, listen, this is what I'm getting, this is what this site is getting, there's a problem, fix it. Okay, so that's what these tools are there. They're there to help you, provide you with information that you can use and turn around, use and provide to your ISP and tell them, listen, the problem is obviously somewhere that you have to investigate and solve for me. The subnet calculator is great because it's if you're dealing with a lot of subnetting, it'll tell you, the starting range, the starting IP and ending IP of a range if you're not familiar with subnetting. So it's a great tool for that. And the last 2 links are used for speed testing of your internet link. So let's say you have a 10 megabit link for your internet, and people are complaining that it's slow, right? What you do is you run these tests off hours when nobody's using the internet link. So it cannot be blamed for other things, because if you run these tests during the day and everybody else is using the internet link in the office, then the results you're going to get will be skewed. They'll look very poor. It's because this test is competing with everybody else in the office trying to access the internet. So you want to run these tests when nobody else in the office is using the internet. So for instance, if you're running this at 10 o'clock at night when nobody's using the internet at the office, and you run these tests, and the download speed, the max you're getting, let's say you run the test 4 times or 5 times, and the average or the maximum you got is 5 megabits per second download, and you're paying for a 10 megabit download, then again, it's ammunition you can provide your ISP and listen and tell them, listen, I'm not getting what I'm paying for. These are the results I'm getting. Fix it. Okay, so this is nice. This is really what I like about these tools, is they help you justify and confirm the problem that you're seeing. Another useful information that I have here is again, based on the RFC here that you're seeing on the screen, I highlight the IP addresses that are considered private IP addresses. So if you're designing a network from scratch, let's say you're setting up a new office, a branch office, you can use that information to know what IP addresses you can use as far as private IP addresses are concerned, so that you don't use a public IP address by accident to use internally. And I also use the subnet mask table here because I don't remember necessarily by heart how many, let's say, how many IP addresses are available in a range. So if, for instance, if somebody tells me here, I have a /28, I can quickly look at this table here to tell me, oh, that means I have, 14 usable IP addresses that I can assign to devices. And so this tool is great for this, right? So because let's say a /29, for instance, right? A /29 basically tells you it's a range of 8 IP addresses. But out of that 8 IP addresses, the first and the last are not usable. They cannot be assigned to a device because the first IP address is the network ID, the last IP address is the broadcast. Therefore, the addresses in between are the only ones that you can assign to devices. Okay, and if the /29 refers to an internet link, then it's not really 6, it's really 5, because one of these IP addresses is used by the ISP router. The default gateway of your firewall will be the ISP router. So really, in your case, as far from an internet connection is concerned, you only have really 5 usable IP addresses. And sometimes, that's the way ISPs will sell it. Here, we're selling you 5 IP addresses. So what that really means is it's a /29, and one of the IP addresses is already reserved for their router, so therefore they're going to give you 5 IP addresses that are left in the range that they're assigning you. Okay, and the bottom part is just because at some point in the office we were doing a lot of different fiber work, connectivity, and people were talking to me about the type of connectors. Is it an LC? Is it an SC or ST connector? And I couldn't remember what they look like, so I kind of grabbed this from somewhere and I put it on this sheet. This slide here is basically there to highlight the fact that don't assume or rely on the accuracy of auto-negotiated speed and duplex. I'm saying this because I've seen some weird results where when you inquire on the device what speed am I at, it says auto-negotiated, but it tells you I'm 100 full duplex, for instance, right? But the performance does not indicate that it's really that. Your performance that you're experiencing is a lot slower. Okay, so I kind of came up with a rule of thumb here, whereas if you're able to set the speed and the duplex on the switch port where let's say your computer is connected to, set it. And at the same time, if you're going to do that, also set it on your computer. And they obviously need to match, right? So if your switch port can only do 100 megabit full duplex as a maximum, then your computer should be set the same way. Also, what I've noticed is if you're going to use these what I call the residential switches that you can buy, let's say at Best Buy, these switches are usually, they're not managed, which means that it's a plug and play kind of thing. You cannot configure the ports. You cannot do anything on these switches. So if you're going to do that, then the device that you're going to be connecting to these switches should be set to auto-negotiate, because these little switches don't necessarily react well when the device that you're using to connect to them is forcing a speed or forcing a duplex. It wants to auto-negotiate things. Okay, so, and again, the best way to confirm that you're getting the optimal speed is to do a transfer test. And again, it's a bi-directional test you want to do, right? For instance, let's say you have a PC and you have a file server, right? And you want to make sure your PC is set up properly. So what you do is you take a decent sized file, let's say 100 meg, so something that lasts more than a few seconds, right? It takes like 10-15 seconds to transfer. So what you do is you just use simply Windows Explorer, right? You click and drag the file from the server to your local desktop on your PC here, and then you look at the transfer status bar going across the screen on your Windows, right? And you see that it's gradually non-stop going, right? So that's what you want to see. You want to see a consistent speed and that doesn't stop. Okay, and then what you do is once you've transferred, let's say, the file from the server to your PC, you rename the file on your desktop, and then you drag it back to the file server, and then you observe again the transfer speed. Because I've noticed that oftentimes if you have a speed mismatch, either duplex or a speed mismatch. In one direction, it's going to go smoothly and quickly, but in the other direction, it's going to go a little slowly, but it's going to pause once in a while in the process. So when you see pauses like that, right away that tells you it's not set up properly. It's not set up optimally. So you need to change either your PC or the switch port that you're connected to, or the server side Ethernet port, or the port on the switch where the server is connected to. Okay, so what you got to do is you got to find the optimal solution, the optimal configuration. So what I'm showing here, basically there's 4 possible combinations between a switch port and a device. Both sides can be set to auto. You can force both if you can, right? Obviously, if a switch cannot be configured, it cannot be configured. And then you can have one side that's auto and one side that's force, and vice versa. Okay. I would also say, don't assume that, let's say for instance, all Dell computers or desktops behave a certain way. For instance, if you have an Optiplex that you bought 2 years ago, an Optiplex, let's say 7000, and you found that for that one you have to leave things auto negotiate, and then the following year or 2 years later you buy another Optiplex, but this time it's an 8000 series. Don't assume that what you did on the previous one is going to also work for this one. Dell often changes network cards in their computers, so you got to make sure that you always do that test to confirm the optimal speed. Okay. And one last thing about stuff like that is your cabling. If you're going to use a Cat5 cable and both devices that you're connecting to can do gigabit, you're never going to get gigabit, because a Cat5 cable cannot do gigabit. Cat5 cables are rated for 100 megabits per second. You want to do gigabit, you have to use a Cat6. But it doesn't mean that you will not get more than 100 megabit if you're using Cat5. But all I'm saying is you're not going to get gigabit. You're lucky if you're going to get 500 megabit. Chances are you're probably going to get 200 or 300 megabits per second with a Cat5 cable. But if you want to get as close as possible to gigabit because your devices can do gigabit, then you need to use Cat6 cabling. And cabling, any patch panels that you're using on the wall, any connectors that you're using, all that has to be Cat6 rated in order to be able to sustain the gigabit performance throughout. And I think this is probably my last slide here. What I've done is I came up with this slide because I wanted to quickly glance. Sometimes people tell you, well, how long is it going to take to transfer this file from my PC to the server? Or how long is it going to take to transfer this file from Houston to New York, right? So you have to determine, first of all, where's your slowest component in the link. So, for instance, let's say I'm using I want to transfer a file from Houston again to New York, and the slowest component in this here is my internet link in Houston. My internet link in Houston only does 10 megabits per second, and the one in New York, let's say, is a lot higher than that. Let's say it's 50 megabits per second. Okay, so you have to use your slowest component here. So if let's say you want to transfer a file from Houston, and the file itself is, let's say, I don't know, 180 meg. Okay, how long is it going to take to transfer a 180 meg file from Houston to New York? So the fact that I have a 10 megabit full duplex link in Houston, right? I'm going to be able to transfer this 180 meg file in about 3 minutes, because according to this chart here, at 85% throughput, is I can transfer about 65 meg per minute. So 180, it'll be a little less than 3 minutes. Okay. Now this is assuming obviously that there's really nothing else using my internet link in Houston, and there is no bottleneck anywhere along the internet, right? This is almost like optimal speed. Okay. Now let's say we're talking here 65 megabytes per minute here, so I'm saying 3 minutes. So if it takes you 20 minutes, then obviously there's a problem somewhere, right? So the problem could be maybe your local internet link is saturated. It could be there's a problem along the internet. That's the problem. Or it could be something else. It could be you have a speed mismatch on your local PC. So I've kind of explained here or highlighted some of the culprits why you would not be able to get close to the 85% throughput that I'm referring to here, right? It could be devices are overloaded. It could be a faulty driver. It could be a faulty physical port, or these kind of things. So it's kind of nice to look at this chart because you can quickly glance. I never use the theoretical 100% throughput because, again, it's theoretical. In reality, there's always some delays due to distance or due to other variants. So to me, the 85% throughput is always the chart that I use to estimate how long things are going to take to transfer. So I really hope you enjoyed this little tutorial, and I look forward to talking to you again. Thank you.